Recording in progress.
Okay, now I'm going to share my screen. My screen visible? Suraj?
But your voice is low.
The last turn I have completed try, catch, finally, and throws. Today we will try to use throw. So through the throw, we can the last keyword is throw. So we can use throw keyword for throwing the object of exception class, and we can create user defined exception. So what is the meaning of this? Actually, all predefined exception arise at a specific situation, if a specific condition. Like suppose if you are trying to divide by 0, then it will arise. If input mismatch, suppose we have need of integer and we will try symbol or later, so input mismatch by exception will arise. But suppose we want to arise the exception at user specific situation, a specific condition. So for this purpose we use throw. Okay. So for throw we can use object of any exception predefined, like we can throw, because all classes are predefined, are predefined classes, so we can throw the object through the throw keyword. Okay. So now I'm going to create an example of throw. Now I'm going to create a new project, Java project. If you have need the examples, I will share it. Okay. New class. Suppose we want to arise the exception. A student will get, if a student will get get a 100% marks. So I want to arise a exception. Okay. For this purpose, I'm going to create an example. If a student will get a 100% marks, then a exception will arise. So for this purpose, import java.util. All exceptions belong to util package. Sorry, Java package. No problem. We are talking about this. Scan sc is equal to new. Suppose we want to execute this example 5 times. If you want to use if you want to use throw, so must be use try catch. But this is a user defined situation, so we will use user defined message like okay. Enter the marks. So int marks is equal to next int, and after that we will check. So if we want to use through keyword, so must be specify a condition. Like if marks is equal to 100, okay, then we want to throw a exception, arithmetic exception. You can use any predefined class for exception, no problem. Predefined exception class, arithmetic exception, IO index, array index, bound exception, number format exception, IO exception. You can use any class, exception class. Arithmetic exception. Okay. Else we can specify another condition. enter marks. If marks is equal to 100, then arithmetic exception will arise. Okay, and it will show a message, well done. Okay, otherwise if marks is greater than 70 and less or equal than 100, then it will show green zone 60 and 70, and less than 70, then amber zone 0 to 60, red zone, otherwise invalid marks. Now I am going to execute this. You can input any marks, like suppose 100. Well done. Enter the marks. Red zone, green zone, amber zone, invalid marks. Okay, but suppose here we can use any predefined exception class. We can throw any object of any predefined exception. We can define any class here, and here we can specify the exception in catch. Okay, but suppose we want to use a user defined class, so it is also possible. I am going to create a copy of this. Okay, suppose we want to use a user defined class. So at the place of this, we can declare any user defined class. Okay, so obviously here we can change it. Catch, in catch we can use group, but this class is not exist, so we have need of this class. So here after this class we can declare this. Do exception, but here you can see this it did not resolve. Okay, so for this purpose must be extend, because this is the user defined class, this is not exception class. For this purpose we want to convert this class in exception class. So we have two options. We can extend exception class. Okay, and you can see this resolve. Now you can see this. Marks, red zone, 100. Well done, it's working. Okay, so if you want to create a user defined class, we can throw the object of user defined class, but must be exist this class. Okay, so for this purpose we can create a class and exception or runtime exception. We can use any one, exception or runtime exception. We can use any one. Okay, if we will use exception, you can see this. I am going to execute it. It will work, no problem. We can extend a user defined exception through runtime exception or exception. If we will extend exception, so this class will be a checked exception, and if we will extend runtime exception, so this class, user defined class, will be a unchecked exception. Okay, that is the difference between exception and runtime exception. Okay, now suppose here we want to pass any message. You can also pass any message from here, like exception case. This is I am passing here parameter in constructor. So here declare a constructor public guru exception string, and here you can print the constructor. Okay, now again I'm going to execute it. And you can see the exception came. Well done. Okay, so we can also pass any message to the constructor, and we can read through the constructor. We can print the value of constructor. Okay, understood? Any doubt, any queries, Suraj?
No, sir. I'm understanding.
Okay, okay. So these were the exceptions, exception handling, throw, throws, try, catch, finally. Any doubt, any queries?
No, sir.
Okay, thank you. Now we are going to next topic, that is a multi-threading. Okay, multi-threading. This is very important concept of Java, because Java work on multi-threading concept. So here we are going to explain a multi-threading concept, but actually Java only works on multi-thread. Okay, main function is also a thread. Okay, so all framework like your Spring and Hibernate and your JDBC and collection, these are example of multi-threading that work on the basis of multi-threading. Okay, so first of all try to understand what is multi-threading. So here this word is multi-threading. We can write it as multiple plus thread. We can write it as, okay, multiple means many, and here one thread, actually one thread represent one task, means one thread perform one task. Okay, so multiple thread will perform multiple tasks. Okay, so we can say if we want to perform multitasking operation, we use multi-threading. Multitasking means if we want to perform, we want to execute multiple programs, multiple tasks simultaneously. So we use multitasking. Okay, so actually one thread perform one task, so multiple thread will perform multiple tasks. So if you want to perform multitasking operation, you use multi-threading. Okay, because one thread perform one task. Okay, so we can execute multiple thread simultaneously through the multiple tasks through the multi-threading concept. Okay, so what is multitasking operation? So like suppose here you can see this, currently we are using STS, we are using Notepad, we are using Zoom. Okay, so multiple software we are executing simultaneously. Okay, so same operation if we want to perform through our program, so we use multi-threading concept. Currently we are using only single program we can execute it, but through the multi-threading concept, we can execute multiple program simultaneously. Okay, so actually multitasking operation we can perform through two types of, you can say, two types of multitasking operation. First is process based, and second is a thread based. Okay, what is process based? What is process? So I think you know that. Suppose I think you know that is a block diagram of computer. We can input this is the output, man memory, CU, ALU. Okay, so we can input anything like command or data. We can input anything through the input device. Okay, so we can input any data, any command to the input device that will reach at CU. CU is a control unit. It will work as a like a manager. It manages the all operation. So it will check which type of request received from the front end, from the user end. So if it will get the any request for text based, so that will check in the main memory the answer of that request. If it will get, then it will show on the output screen or printer, that is the output devices. So that is called information. It will print, it will send to output device like video, a monitor, console, or printer. That is called information. But if suppose C will get the request for any type of calculation like logical calculation or arithmetical calculation, so it will transfer that request to ALU, arithmetic logic unit. It will calculate that operation and store the result in a main memory and send a copy of that result on the output device. That's called information. Okay, so except input and input, this area perform the operation in here, that's called process. Okay, and our CPU perform the all type of operation, all type of process in our system. Okay, CPU will perform all operation, all process in the system. Okay, so actually CPU perform two types of process in our system. First is heavyweight. Heavyweight process, and second is light weight lightweight process. Heavyweight process, it consumes a space in the memory, plus it have a process ID. A unique process ID. Okay, suppose we are using Chrome, we are using Microsoft Edge or any task. So Word, Excel, PowerPoint. So it consumes space in the memory and it have a process ID. Okay, actually we know that this is a Word, Excel, PowerPoint, but suppose if you don't know about the Word, Excel, PowerPoint, okay, it generate a unique ID for each process and identify that process through that process ID. Okay, so all heavy weight process, it consumes the space in the memory and it have a unique process ID, and through this process ID our CPU our system identify that process. Okay, but lightweight process, it does not consume any space in the memory and it have not process ID, but you can say without space how to execute. So actually it uses space of heavyweight. What is the meaning of that? Actually all lightweight process execute within the heavyweight. Like suppose here, suppose a heavyweight process is executing. So for this purpose it will acquire a space in the memory. Acquire the space in the memory. Okay, but the lightweight process will execute within this heavyweight. It will not acquire a separate space in the memory. So you can execute, you can create a lot of number of lightweight, because lightweight process does not consume a separate space in the memory. Actually it will execute within the heavyweight. What is the meaning of this? Actually suppose here, suppose we are using Word, MS Word, sorry, not WordPad. Okay, so if at the time of writing any message, like suppose here I want to type here anything, okay, like here you can see this. If spelling mistake, then it will show red underline. If grammar will mistake, then a green underline, a green color line will display. Okay, what is the meaning of this? Means a program is executing in the background that is checking our spelling. If a spelling will be mistake, it will show a red color underline. If grammar mistake, then it will show a green color underline and a blue color underline. Okay, same as you will get it in you at the time of writing a email. Okay, same as you will get in WhatsApp. Suppose you want to type a message to your friend in WhatsApp. So if you press any key, any alphabet, automatically you can see some suggestion will appear on the top of your keyboard. Okay, then again you press another key, then it will show another suggestion on the top of keyboard. It means a program is executing within the WhatsApp, that is checking your keyword, your letters. Okay, after that it will provide the suggestion. So it does not acquire extra space in the memory. Actually it is executing within the WhatsApp. This program is executing within the MS Word. that is an example of thread. Okay, thread is executing the background, that is not acquiring extra space in the memory. Actually it executing within the heavy weight, so it does not acquire extra space in the memory. It is not using any process ID. Actually it is executing in the heavy weight. Okay, like any heavyweight process. In the heavyweight process, multiple lightweight process is executed. Okay, so actually heavyweight, so lightweight process execute within the heavyweight, so it does not acquire any space in the memory and it have to have a process ID. Okay, second thing, so here multitasking is two types. First, process based, and second, thread based. We cannot perform process based multitasking because that is the characteristics of operating system. Operating system perform process based, that is the characteristic of operating system. Like just like Windows is a multitasking, Linux is a multitasking. Means we can execute multiple programs, multiple software at a time, simultaneous. Like here you can see we are using Word, Paint, Chrome, and STS. Okay, so simultaneously we are using multiple programs, multiple software. So that is a characteristic of operating system. We cannot perform it. But Java provides a multi-threading concept. On the basis of multi-threading concept, we can perform thread-based multitasking. Okay, so if we want to perform multi-threading concept in Java, so for this purpose, Java provides us two options. First, runnable interface, and second is a thread class. We can use any option and we can create the thread. Okay, so Java provides us a multi-threading concept. Through this concept we can perform multitasking. Means we can execute multiple programs at a time. Simultaneously we can execute multiple programs. We can perform multiple tasks. Okay, so if you want to perform multitasking in Java, so we use multiple thread, because one thread we can execute to one program through the one thread. So we will create multiple thread and execute multiple program simultaneously. Okay, so for this purpose Java provides us runnable interface and thread class. Okay, so how to use it? Suppose we have a class and we want to convert this class in thread. So it is very easy. Only we can implement runnable interface or thread class. Okay, so the demo class will be a thread. So if you want to use thread, so only implement runnable interface or thread class. Okay, after that, actually interface runnable have a method name is public void run. Okay, actually runnable interface a method public void run. So this is our responsibility to implement public void run method. Means if you want to execute any program through the thread, we can write within this method. If you want to perform any task through the thread, so So we will write the code of that task within the run method. Okay, same as if we extend thread class, we implement public void run. In both situations, we will implement public void run method. Either we are implementing runnable interface or extending thread class. Okay, but you can say why we are using public void run in thread class. So actually, thread class is also a predefined class, and it already implementing runnable interface, and it does not implement public void run. So this is our responsibility to implement public void run. Okay, and thread class provides us multiple methods like start, sleep, set name, get name, join. There are multiple. The thread class provides us a lot of methods. Okay, but runnable interface implement only a public void run method. So this is our responsibility. So implement public void run, because thread class does not provide us the implementation of public void run. So this is our responsibility. Okay. So we have two options: public void run and runnable interface and thread class. We can use any method and we can perform the multi-threading concept. Okay. Now I'm going to create example. Okay. Okay, Suraj, any doubt?
No, sir.
Okay. Now I'm going to create example. Here, suppose you want to check any thread is executing in the background or not currently. Okay, so for this purpose, I'm going to create. I have a method name is dot current thread. It returns the object of current executing thread. So if you want to check any exception, any thread is executing currently in the background or not, so we can check through this method. That is a current thread. It returns the object of current executing thread. Okay, this is a static method, so we have not need the object of this class. Okay, so the class name we can call current thread method. Okay, and we can save in the reference of thread class. If you want to print the name of that thread that is executing the background currently, so here you can print it thread name plus t dot get name. Okay, now execute this. So you can send this thread name main. So actually this main is also a thread. So our all program execute through the a thread that is name is main. And if we will create the user defined thread, so main method will execute our user defined thread. Okay. So actually main is a thread, and through thread we can perform the all operation. can also execute the user defined thread. Okay, so now I'm going to create a user defined thread. So I'm going to create a class like suppose I'm going to create a class and name is first. Okay, click on finish. So if you want to create convert this class in thread, so we have two options. We can implement runnable interface and thread class. So first of all I'm going to use thread class, after that we will use runnable. Okay, so extend thread. Okay, and implement public void run okay, and we are going to perform operation, any operation in this. Suppose we want to print the thread name 10 times. Okay, so for this purpose I declare one first of all we have need the name of current thread. Suppose we want to print name of current thread. Okay, but this is user defined thread, it have not any name, so we can set the name of this thread like here. Okay, so 10 times it will execute, it will print the name of thread. Okay, same as suppose we want to create multiple thread. Same as third thread. Okay, we can create multiple thread. Here we can change the name. Okay, like second thread, same as we can change the name. Third thread. Okay, now suppose we want to execute this thread, these three all thread, okay, simultaneously. So for this purpose, first of all create the object of this class like user defined thread, like t1 is equal to new first, second t2 is equal to new second, third t3 is equal to new third, t1 dot start. Okay, if you want to execute these thread, we use start method. So t2 dot start, t3 dot start. Okay, and we can execute it. And you can see this first, second, first, second, and where is third, and at the end of third. There is no sequence. If we will execute again, it will show a new serial. Here you can see this. Third, first, second, first, third, first. You can see this. All thread is executed one by one. Okay. So if you want to show that all thread is working simultaneously, so you can see the third, first, second, first, third. We cannot set the sequence of the execution of the thread. Okay, that will understand through the life cycle of thread. Okay. But suppose you want to see it, how it's working, and actually it's executing simultaneously. So we have another option. We can also break the execution of thread for some time. Like suppose here I'm going to use another method. One minute. You can see here. Must be know that I'm going to use a method of thread that is sleep. It will break the execution for some time. Like that is also a static method, that is a sleep. Okay, here we can pass suppose 1000. Actually this is a millisecond. So means 1 second break the execution of this thread. Okay, it's throwing exception. You can see this. Okay, and it's throwing exception name is interrupted exception. Okay, so actually interrupted exception is a checked exception. You see here. Okay, so at the compile time, our compiler forces user to put the exception handling programming code. So here this is a checked exception, can be arise in multi-threading concept. Interpret exception. Okay, save this file. Same things we can use in second. Okay, and change the name. Okay, and same as we can declare here. Third. Okay, now you can see the all thread will execute simultaneously. You can see this. So you can break for some time. I'm using here sleep only for the break the execution of the thread for use sleep method. Okay, and you can specify the time, like second, suppose 1 second or 2 seconds. You can as you need, you can specify here, but the processing will be slow if you are using sleep method. Okay, suppose we want to perform same operation, so that is the execution, that is the example of thread through the thread class. But suppose we want to perform same operation through the interface runnable. So I'm going to copy this project and try to use runnable interface. Okay, so for this purpose I'm going to use runnable interface at the place of thread class. So implement, because runnable interface, so we use implements keyword. Same thing we are going to use in other thread. Okay, here you can see this is showing error because start method is a part of thread class. Start method is not exist in the enable. So if we want to execute this thread, it is not possible. Okay, so how to perform it? So for this purpose we have need the start method, and start method belong to thread class. So for this purpose we will create the object of thread class, okay, and pass the object of this thread in the constructor of thread class. Like T2 and T3. Okay, now we are going to execute, change the name of thread. Now we are going to use XYZ at the place of T1, T2, T3. Okay, first, second, third, object of first and third, user defined class. After that we will put the object of thread class in the constructor of thread class, and then we can execute it and we can get the start method. Okay, now run as, you can see this. So if we want to use runnable interface, so first of all create the object of user defined thread. After that object we will pass in the thread class, and after that we can use start method. But suppose we are using a thread class, so we have not need to use this instruction. Directly we can call through the class, through the user defined thread object we can execute it. Okay, like here you can see this, we can directly call the start method. Okay, but runnable is better than thread class because the runnable is a interface that is faster than thread class. Okay, we can also perform multiple inheritance also if you are using runnable interface. Okay, that is the difference between runnable interface and thread class. Okay, second thing, if you want to write the program of main thread, so it is also possible. You can type here, like suppose int I is equal to 1, I less or equal than 10, I plus plus. Okay, and we are going to use here we can execute this. And we have not to set the name because this is a main thread. Here we have need thread dot sleep for 1 second, same. Okay, now so this is a program of main thread. We can also write the program of main thread here. Okay, now I'm going to execute it. You can see here because it is main thread. Okay, so we can also write the program in main thread. Okay, so these are simple examples of multi-threading. Okay, we can use thread class a runnable interface to perform multi-threading concept, and here we are creating a simple program just like they only print the name of a current executing thread, but you can perform any operation through this thread, and you can execute a lot of programs simultaneously through the multi-threading concept. Okay, okay, Suraj.
Okay, sir.
Any doubt, any queries?
No, sir.
Okay, thank you, Suraj.
O- Okay, sir. Thank you. Have a good day.